This dashboard presents normalized annual point data representing max height of snow data for stations across British Columbia. There's two main maps on this dashboard, each with a different type of normalized point data. The default map, map 1, shows annual percentage of average, and the points values are represented here in this map 1 legend panel. So you can see the average values. Average would be 100%. So the range is 90 to 110. It's represented by a medium yellow circle. Anything above average starts to go into greens and blues. The circles get larger. And anything below average goes into orange and reds, with the circle getting smaller. So right at a glance, we can sort of see trends across the province. As we zoom in on the map, the circle icons are populated with a label, and that label represents the exact value for the station. So we can see in the center of the map, north of Kamloops, there's a blue circle with 145. It means that station was 45% greater than average for the 2021 winter, which is the default showing here. So we start to see trends across the province, a lot of yellows and greens through the center of the province, orange and reds through southeast BC, and we start to see more blue circles as we head north and towards the coast. There's a lot of data showing by default, so at the beginning here we may want to filter some of these points. The first notable one that's important on all of these dashboards is the snow course data. The problem with the snow course data is that the samples are only taken once per month, so we're probably not capturing the actual max height of snow for that year, but it gives us a pretty good sense, since in most years there's 3 or 4 values taken throughout the winter. While it may not be perfect for capturing the actual values, because this is such a large data set, it does still show us interesting trends. That being said, in the more recent years, in the last, say, 20 years, as there's been more and more telemetry, automated snow height measurements come online, we may need to use the snow course data less and less in our analysis. So what I'm going to do is just turn it off here. Now we're only looking at stations with continuous data throughout the winter. So this is more reliable, but there's just a lot less of this data available. So now we start to see pretty similar numbers to what we had before, just less of them. Me as an avalanche forecaster, I'm generally more interested in higher elevations. So I might crank this up to, say, around 1,000 meters. Now I'm only seeing the higher elevation stations, and what's immediately apparent is all of those small red points are gone from the map, suggesting those are mostly lower elevation points that had well below average snowpack in the 2021 winter season. This one, the third filter, shows the average max height of snow at each station. So again, I'm mostly interested in the wetter stations with deeper snowpacks, so I might turn this up to 1.50 meters. So I'm only seeing stations that have at least 1.50 meters average max HS. You can see we're starting to see a lot less points. Now we're just looking at wetter, higher elevation stations. So we're seeing a lot of stations around average, a couple slightly above average. There's still a couple slightly below average. But you can see how as we narrow down the points, we sort of can create a more specific picture depending on what we're interested in looking at. So I'm going to reset this. If we were in charge of maintaining highways, we may be interested in the opposite. We may want to turn the elevation down. the highest elevation highway in BC is Kootenay Pass at around 17 or 1800 meters, which is a very high pass. I'm going to set this a bit lower than that. What you can see if we go even lower is all of those red and orange points are all quite low elevation. So that was definitely a noticeable trend in the interior of BC last winter. We had an average snowpack in the mountains and well below average snowpack deep in the valleys. This is an interesting analysis. It's pretty easy to grasp the percentage average data. We can click back through historic times, reset these filters, and very quickly we can see trends for each year as we click them. Notable year 1999. I'll turn the snow courses back on. You can see a further back in history we go, the more reliant we are on the snow courses. So here's 1972, another big winter. Just to compare it, there's 73 below average winter. So these big winters do stand out. And just to show you here, 1972, if we turn off the snow courses, we're not left with a lot of stations. So this is really where the snow course data is useful, is when you go back in history. Another biggish year was 1967. I saw lots of blue there. We can see sort of typical years, see a more yellow and maybe a bit more mixture of blue and orange scattered around. This data goes back to the late 30s, mostly. Seems like a lot of dry to average years through the 40s. No real big years popping up. Now onto the second map. I'm going to reset the filters are already reset. I'm going to go back to 2021 and go to the second map. The second map normalizes the height of snow data using Gumbel extreme value statistics. As you can see, the legend on the right hand side of the map shows 6 orangish circles of varying size. These represent the estimated return period based on the statistical analysis, which is described in the other video on data preparation. But the general idea here is big winters with deep snowpacks should show larger estimated return periods, so we should see larger circles. There's a few medium circles in this 2021 data set, but mostly we're seeing smaller stuff, so it wasn't a really statistically significant winter for us. We can again just click through the years. Since all the data is preloaded, this is really quick. We see a clustering in the interior plateau, Okanagan area in 2018, and some bigger circles up in the north coast inland. There's another interesting year where all of the north was not statistically significant, while we saw some in the south. I'm going to go back, jump back to 1999. Another big winter through southern BC and south coast. Lots of large circles. As we zoom in again, we see the actual estimated return period populate the circle. So we're seeing some 50 to 100 year stuff on the coast, maybe 30 to 100 year stuff through the interior. But again, we have lots of points with small values, so we may want to play with our filters again. And this is, I think, an especially important one, that where snow courses, because of the variance that exists, since they're not measured continuously, and you are almost randomly sampling once a month through the winter. I think this is overestimating estimated return period. So this is one where you definitely want to turn off the snow courses and see how it changes the data that's on the screen. So turning off the snow courses, we're back 22 years. So it's not there's probably a medium amount of points going back this far. Once we get back into the 80s and 70s, we'll start to see them drop right off. But for the most recent years, there's quite a few points here. With snow course turned off, 2021 really doesn't show any significance. 2018 was the last year in southern BC where we saw, some big circles in 1999. But again, we may want to play with our elevation filters. Just look at high elevation. Maybe we want to just look at low elevation. The one other filter I included on this dashboard for this map specifically was the number of years in the data set. If you were doing true like climate change analysis type of analysis, you'd want generally at least 30 years of data. The reason I included some of the stations with less was just because there's quite a few really good highway stations with like 20-ish years of data. It's all electronic data, so as we progress in the next few years, we're going to have quite an abundance of electronic data with 30-year data sets, which is great. The interesting thing here is you may find stations with outliers. This may actually show you if you have trends across the province that are showing lots of small points, we may see one point that stands out. Click through year to year. So here's an example of an outlier where all the points are showing very small to the point where you can't even see them on the map. There's one down here by Nelson that's showing a 1-year estimated return period. But here at Silver Star, outside Vernon, we're seeing a 51-year return period. This is at Environment Canada station. So if we're potentially more interested in this point, what we can do is we can move over to our next dashboard, which is the station info dashboard. So progress to the next video and we'll dig into the Silver Star station.